Lesson 14, Transient Response. Section 14.3. Observations on transient response of RL circuit. We have observed the transient responses of VR and VL of this RL circuit. I have two questions. The first one is, why are VL equals V volts, and VR equals 0 volts, at t equals 0? The second question is, what are the values of di dt, dVR dt, and dVL dt at t equals 0? This is the answer to the first question. The equation VL equals L di dt means that the current I flowing through an inductance cannot change instantaneously. Because a step change in current would cause di dt to be infinite. Therefore, an infinite voltage would be required to change the current instantaneously. We can apply only a finite voltage to this RL circuit. The initial condition is, I equals 0 at t equals 0. Thus, VR equals Ri equals 0 at t equals 0. The inductance opposes the step change, so VL equals V at t equals 0. This is the answer to the second question. From VL equals L di dt. Di dt equals VL over L. At t equals 0, the inductance voltage VL equals the source voltage V. Therefore, di dt at t equals 0 is given by V over L. From V equals Ri. dVR dt equals R di dt. We derived that di dt equals VL over L. Thus dVR dt equals R over L times VL. At t equals 0, VL equals V. Thus, dVR dt at t equals 0 is R over L times V. The inductance voltage VL equals V minus VR. Then dVL dt equals negative dVR dt. From the above, dVR dt equals R over L times VL. Then dVL dt equals negative R over L times VL. Therefore, dVL dt at t equals 0 is negative R over L times V. Exercise 14.3. This is your homework. Pause the video, and answer the questions. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.